How's it going, guys? So in today's video, we're going to discuss the stochastic oscillator. And the way I view the stochastic is it basically interprets price action so that we can find good areas to enter, exit, long, short. And most people, I would say the stochastic oscillator, first off, is probably one of the most widely used indicators, right? Um, and most people generally understand that when the oscillator is real low, you want to go long. When it's real high, you want to go short. So what does it even look like, really? Um, this is what it looks like here. As you can see, it has two lines. Um, this line, this blue line, is much more volatile than this orange line. And this blue line is known as the fast stochastic because it's a lot faster, more volatile. And this orange line is known as slow stochastic. And in our calculations, we will represent the fast stochastic as percent %d, percent %k, okay? So this fast stochastic is percent %k. Slow one, the orange one, is percent %d. Now, most people generally understand that when the stochastic goes below 20, as you can see, we have a range between 0 to 100, and then we have a channel here between 20 and 80. So most people generally understand with stochastics, anytime we dip below 20 and our fast stochastic crosses the slow stochastic, that's a good area to go long. And vice versa, when we go above 80 and slow stochastic our slow stochastic surpasses our fast stochastic, or our fast stochastic goes below our slow, it's a good area to go short. But most people don't really understand how these values are derived, right? And it's not that important, really. But if you're trying to get a fundamental understanding of what these indicators even mean in the first place, it's kind of a good idea to know how these values are derived, right? What are the calculations taking place within the software? Okay, so let's head into it. So the formula of the stochastic oscillator is you're going to take the closing price of the last candle, okay, and you're going to subtract it by the lowest price traded in the past 14 candles, okay, or time periods that you're calculating for. Then you're going to divide that by the highest price traded in the past 14 candles and subtract it by the lowest price traded in the past 14 candles. And that's going to give you a decimal like 0.3, 0.7, and then you're going to multiply that by 100 to get a value between, again, 0 and 100. All right, simple to understand. Last thing to note here is that percent %k is referred to as fast stochastic indicator, like I mentioned, and the slow stochastic indicator is taken as percent %d, like I also mentioned, and percent %d is equal to a 3-period moving average of percent %k, which we're going to get into later. Okay, so here's an example calculation of percent %k, or the fast stochastic, okay? So again, we have a 14 candlestick period, okay? I believe these candlesticks are maybe 1 hour, 15 minutes, I can't remember exactly. But regardless, we have 14 candles. Okay, so this is the first, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, now the close for the candle here is at 39,176. So again, going back to our formula, we need our close first. Bang, found our close, we input it. Then we're going to subtract that by our lowest point in the past 14 candles. Okay, here's our lowest point, 38,000. Boom, we input that into the equation. And now we need to find, we have our close minus our lowest. Now we need to find our high minus our lowest, which we found our high here. It's up here. And we input that into the equation, subtract it by our lowest point here. All right, now we simplify the equation down and we get 0.621 times 100, we get 62. And so now let's verify that with the stochastic. Indeed, we will find at this candle, our calculations came out super close. We had 62.1 in my calculation, and the actual stochastic comes out to 62.3. And the reason it's not exact is because these values here, the lowest point, I didn't get the exact lowest point. It's just slightly off. I didn't get the exact highest point. It's just slightly off. I didn't get the exact closing point. It's just slightly off. But this equation is indeed correct. The math checks out. We're only off by 0.2. Okay, so now that's how you get the fast stochastic. Oh, and also I changed the fast stochastic here to histogram just so we can see that it's exactly there. Because if it was a line, that line's going to smooth this out and it's not going to show the exact point. So I changed it to the histogram to exactly show its exact value for the stochastic at that candle point. Okay, so that's how we get the fast stochastic. So how are we going to get the slow stochastic? How is the slow stochastic's values derived? So that's where these calculations come into place. And remember, back here it said it's a 3-period moving average of percent %K. So all we're going to do is we're going to take a 3-period moving average of percent %K. So this is 1 period, this is a 2nd period, and this is a 3rd period of percent %K. So bar 1, right down here, I guess we're going to use this. Okay, so this is bar 1, bar 2, bar 3. Bar 1, 31, bar 2, 40, bar 3, 62. So we're going to average that out and we get 45.02. Once we average it out, we get 45.02. So then, indeed, we will find that our slow stochastic calculations checked out because it shows right here we're at 45.16. And same deal here. It's not exact because I just didn't get the exact values for each of these points, but the formulas check out. So that's how slow stochastic is derived. It's just an average of the previous 3 periods for the K stochastic, or the fast one. All right, now the thing with fast stochastic is that it can sometimes be super volatile to where it's almost useless, or it's not useless, but just harder to read, right? Like imagine if fast stochastic just kept going up, down, like super volatile. It's not going to give you a clear path of where it's heading. Instead, what you can do is you can smooth it out by taking more data in and averaging it. So the way smoothing works is you're basically just averaging it across a period. So if you want to do a smooth factor of 2, all you're doing is you're taking this period of the K value and the last period of the K value. So now you have 2 periods. You're going to add the values together like we did here. Here we did the 3 bar here and the 2 bar here. So then we got 62.8 plus 40.51, and we averaged it. And so the smooth factor of 2 gets us 51.65 for this bar. So this bar will now become 51.65. Pretty simple to understand, right? All we're doing is just averaging it. Now, if you would have done a smooth factor of 3, then you would have had to add the value of this bar, the value of this, the value of this, the value of this, the value of this, divided by 3, and then you just average these 3 bars to get this bar. Super simple to understand. That's the way smoothing works. And if you do the smooth factor of 10, you're taking the previous 10 bars and averaging them. And here we find that my math does check out again. We got the smooth factor of 2. And after we did it, the bar moved from what was previous. That's like 62, right? Yeah, 62. And then it goes down to 51 right here. And you can see that's where it was before. Okay, and that's it. You know, that's basically how the prices are derived. I hope this content was helpful. If you have any questions or comments, just leave it in the comment section. Feedback. If I kind of sped through something too quick and it didn't make too much sense, just ask away. Alright guys, I hope you liked the content. I would greatly appreciate it if you liked and subscribed. If you have any recommendations for future videos, leave that in the comment. But thanks for watching.